a video that I forgot to put in earlier, so I'm jumping to video 76. Make sure you have a look at this one once you've done factorizing quadratics, and as well, it's probably a good idea to go through this one before you have a look at simultaneous equations and quadratics, otherwise it might be a bit difficult. When we looked at factorizing quadratics, we had an equation where we just had an x squared. So it might have been x squared plus 2x plus 3, and we had to factorize it, put it into brackets, kind of the opposite of FOIL when we covered that. But what do we do if we've got more than one x squared? What if we've got 2x squared or 3x squared? So for instance, if I'm given this equation by here, I would expand it first of all. And I'm given this equation 3x squared minus 2x equals 5, and that leads us to a problem. We haven't got the x squared like we did when we were doing the first part of factorizing quadratics. We've got 3x squared. For the moment, I'm going to just ignore that. I'm going to move the 5 to the other side to give me 3x squared minus 2x minus 5 is equal to 0, because when you're solving quadratics, you want the value to be equal to 0 for that last stage, which you've seen in the past when we look to see what x would be if the equation in the brackets is equal to 0. Now, just like before, I'll open up brackets. And remember that the reason why we put an x at the start of each bracket when we had an equation with just x squared in is that when you multiply the first, as you do in FOIL, you'll have x times x, which is x squared. In this case, we want 3x squared. So if we make one of those x's 3x instead, when you do FOIL and multiply the firsts, you're doing 3x times x, which is 3x squared. Unfortunately, there's only a limit to the number that they'll give you with this. Remember that if they give you 2x squared, then one of them will be 2x and the other one will be x. It's the only combination to get 2x squared when you multiply them. Then 3x squared will give you a 3x and an x. Again, it's the only combination to get 3x squared when you multiply them. The only complicated one, which they're unlikely to give you, but it's a minor possibility, is if they give you 4x squared, in which case there are actually two possibilities. It could be 4x times x to give you 4x squared, or it could be 2x times 2x to give you 4x squared. So you've got more numbers and combinations to work with. In this case, though, we're dealing with 3x times x. Now then, just like in the other one, we have to look to see which numbers will multiply to give us the c, the last constant number on its own. In this case, we've got the number minus 5. So the only two combinations we can have is minus 5 times 1 or 5 times minus 1. Both of those will give minus 5 at the end. Now this is where the complication comes in these more difficult quadratics. We have to multiply one of the numbers that we have decided on by the number in front of the first x, and we multiply the other one by the number in front of the other x. Now notice I've put the 1 in by here because it was an invisible one. When you've got x, it is 1x. We just don't write in the 1. But to make it clearer what we're doing, we're going to be multiplying the minus 5 by the 3 from this one, and we're going to be multiplying the 1 from that one. But it could also be minus 5 times the 1 from that one, and 1 times the 3 from that one. So I've done then 5 times the 3 from this one, and minus 1 times the 1, and then 5 times the 1 from this one, and minus 1 times the 3. So all the possibilities that you could have had, so we had two possibilities, minus 5 and 1, or 5 and minus 1. I've got to multiply them by 3 and 1. So that two possibilities becomes 4. Obviously, with more combinations, these numbers can get, the number of combinations can get bigger and bigger. So you'll definitely have to write the different things down. But if I calculate those, then it changes into minus 5, add 1, and minus 5, sorry, it should be a 5 times, sorry, minus 15, add 1, because the 3 times the 5 gives the 15, add 1 times 1, so it'll be minus 15, that should be a times symbol by here, apologise, add 1, which is minus 14. We've got minus 5 times 1, add 1 times 3, which is minus 2, and this is all fucking